Forward-looking statements, I guess they apply. It's from last year, so. Who I am, you probably know me already. Integration developer with Aplora. I worked with Splunk for 9 years, many Splunk apps. Member of the Splunk Trust. I wrote a book on the Splunk Developer's Guide, which is how to do Splunk app development, and I'm active on IRC, Answers, and Slack. And you can find me by my handle, Alessio Cogitatis. Who are you? You want to learn search commands. You want to, you work with Splunk in any sort of manner. You have intermediate experience with SPL. You know how to do stats. You know how to do table. So we're going to show you some new commands. You're not going to become an expert on these commands. The idea is that you'll learn them about them, that they exist, and then you take actionable items back to your business to try new things. Quick agenda. We're going to do some administrative generating commands, then some iterative ones, then some statistical things, and if we have more time, SPL hacks or SPLacks, which may or may not be hacks, but they're interesting to know. These are all relevant as of 7.0. I have not tested with 7.1 or 7.2. This is a short list of the administrative generating commands we're going to cover. REST, makeresults, gentimes, metasearch, metadata, and untable, as you can see here. These are commands that they don't pull full events. They're raw. They're used to interact with Splunk, and they provide information about data or Splunk services. First one is REST. The REST command reads the internal Splunk REST API endpoints and then returns the endpoint data. Generally in a table format. It must be the first search command in the search block. It's time agnostic, it only queries, so your picker is not relevant here. And it limits requests to what the requesting user is allowed to access. It does not use the nobody or admin level features, so if your user is just a user and they don't have access to the indexes configuration, it will not show up. But here you can see it's REST services data indexes. This pulls information on the indexes that are installed locally on that Splunk server. And you can see on the right the output table of the list of things. Here is another example of a REST endpoint, all of which are documented at docs.splunk.com. This shows the current authentication context, which means what user is logged in. And you can see I was logged in and I had the roles of Windows admin, admin, and Winfra admin, which is all Windows specific things. But because I ran it, my system, my information returned. So the REST command can use a lot of the internal Splunk APIs, and then you can do other SPL things on them, and stitch them together, and just do investigation if you need to see what the current settings are. Next we do makeresults. It says new in 6.3. It's been around since 6.3. It's really good. It makes fake results. You don't have to specify any other optional arguments. But it runs on the local machine and generates one result with only the time field. And you can see down there at the bottom, makeresults gives time, and the IT is the time that it is now. So it's interesting that you can use this in a sub-search. In this instance here, we're searching internal by index time. And because you can't do eval calculations straight in the SPL, so if I wanted to do now minus 60 seconds for anything that's been indexed in the last minute, you use a sub-search. You return it, and now you can search any of the index times because it's a straight replacement. It's fast, it's lightweight, and you can generate a ton of searches. Gentimes. This is an interesting one. It generates timestamps with the exact time specified from the start, and does bucketing on it. So you can ask it to start at October 1st, end at October 5th, and it'll give you the timestamp buckets of those days. It defaults to day, I believe. But again, it must be the first command of the search, which is useful with map or append. And I haven't found too many real use cases for basic searching, but it's there to help with generating time buckets. And we'll see why this can be important in a little bit. So here again, we start 9 days ago and 7 days ago, increment by 1 hour. And then we just map those time ranges into a search with map, which you'll see in a minute. And your earliest and latest times are there. So you could do disparate time searching across different source types or indexes using gentimes. And here we're just counting items of broken blocks in Minecraft. The really awesome part of this is that even if no searches are returned, you can still have that time bucket in the time chart. Metasearch. Metasearch is retrieving event metadata from indexes based on terms in the logical expression, so you cannot use key equals value searching. It is just keyword only. So it does not extract fields. It does not look at the raw at all. It only looks at the metadata in the indexed source in the indexes. It's good for fast searching of very specific key terms, but it does not tell you what is in the raw. It only tells you where it is with index, source, and source time. And here's an example. Here is an example of it. Metasearch event type is SplunkCraft 2016 over the last 10 years, and it tells you what Splunk server it's sitting on, what index, what source type is source. You can use this with index equals star and then a username, and it will spit out wherever they are in any of the source types or sources that you have. But it will not do user equal username. You just put the username in as a keyword. Again here, this is metadata. Metadata is a command that returns a list of source types or hosts from a specified index or the search peer. It is done by bucketing. It snaps to the start and end time of the buckets of whatever is in the time picker. So if your time picker range covers 2 different buckets, it searches the entire buckets of both those time ranges. And again, does not present raw data, but you can see that first time, last time, the source type in this case, and how many of each. So you can do counts and see how many events are in each kind, and maybe if you're indexing properly. So the recent time important here is the recent time is index time. Last time is the actual configured timestamp that was extracted and stuck. So you could have future events in last time, and that's a good way to check right here. Union merges 2 or more data sets into one. And they don't have to be the same source type, index, or anything. They're just 2 disparate searches that you want to use. You can even use 2 different time ranges in them. They can be transforming or non-transforming, and we'll either do the append or multi-search depending on where they're at and what you're searching. You still will need to respect sublimit or the limits of the sub-searches for the second search that's listed. Here's an example. The first one looks at today in the source smart things, and I say eval marker equals today. And then the second search is look last week, same day, this week, and give me the same index and source type and mark it last week. And then I can do count average color temperatures by the devices and the marker. So fanlight of today at this time and the average color temperature for 2 different time ranges without having to search back over 2 weeks and then doing calculations on what day is actually what using math. This is just easier to just smash the 2 together, add markers, and off we go. Next up are Iterative. Map and foreach. These are expensive. Be careful. You might break something. You might kill a search head maybe. So you need to be very careful with map and foreach. Map is, again, a looping operator that runs repeatedly on each input, event, or result. You can run the map command on a saved search, a current search, or a sub-search. It's very flexible. It uses tokens, denoted by the $sign fields, to pass values into the search from the previous result set. It is very good with very small input set or very specific searches in the map command because you want to keep it small, you want to keep it quick. You don't want 5,000 of these things executing because it takes up a core per. And I don't think they're in parallel either. So it finishes one, then starts another, which is not exactly efficient. But hey, there we go. It is a type of sub-search. It's time agnostic. Time does not necessarily respect the time picker, as we saw earlier with the example of gentimes. So it can be based off of what are the tokens that are being passed into it. So it's generally time agnostic. And here's an example, again, using REST and a couple other things. But here we're taking the index list from REST with the title, and then we map it to the metadata type. So we can say, give me the source types, type equals source types with metadata for the indexes that are passed in. So title in this case was your variable. And then you say the type is title. And then you do a stats count by source type and type, and you can see that the indexes are then there and have the counts with their relevant source types. So you can use metadata to not just show source types, but also where they are in the indexes as well. This is useful for doing things like finding source types that are in more than one index. So this may be a misconfiguration because Apache error should only be in one index in our environment, or it is correct this way. It all depends. Foreach. This is again a iterative command. It runs templated streaming subsearch, which is to say it does lots of interesting things with replacements. You can use this actually to calculate z-scores or perform rapid evaluations or just anything else you want to stick in there. That is a streaming command. You may not use transforming commands, so no table. Although that one may be streaming. I don't know. You can also use wildcards and use match segments. So you can say I have foo_bar equals this and foo_baz equals that. It turns bar equals this and baz equals that. Doesn't make a whole lot of sense when I say it, but you're matching the second segment of foo_star. That becomes the name of the field, and then I give it to the field value in quotes there. And so the second half of foo_bar becomes bar, and that field becomes this. There are use cases for it. I can show you this one. It's a z-score calculation, which is very interesting for normalizing event data against the firewalls and so metrics of that type. So here we're looking at the internal metrics for source type throughput for indexing. We average the kilobytes per second through by 60-minute spans with time chart by the series of SPLANC-D. And then we stream stats. So we take a rolling window of 720 events. We get the mean and we get the standard deviation within those windows. And then we foreach. So basically we say for each of the series that we found, evaluate the z field, the z-score, which is calculated by doing the value, the average value, minus the mean over the standard deviation. So you can calculate that for every single field, for every different series that shows up without having to hard code which series we want to look at. So whatever series are returned in that time period, you just iterate over them. And then we just output the field time and z star, and now we have our normalized z-scores on a 0 to something graph or a negative or a 0 to negative something graph. And I can show you that here. This is what it actually turns into. And then you can do an eval, say give me upper, give me lower. It's 3, and that's my threshold is 3 standard deviations away from the mean. So that's my anomaly. And you can see here maybe that your audit trail has been spiking at the end there, and maybe you need to investigate that now. And then here you can see here's another one with SPLANC-D. It went 3.084, and could just be a one-off anomaly. It could be an outlier. Could actually be a problem. But it's something at least you could look at. Everything else has been normalized, and you don't have to use the logarithmic scale on the chart. Now we'll cover some of the statistical ones. These are commands that build tables, evaluate sums, counts, or other statistical values. So untable converts results from tabular format to a format similar to stats. This is the inverse of XY series, essentially allowing you to undo a table. So what does that actually look like? Well, here's one of the commands, average delay by host, and then you untable it into a decomposed state. It's easier to show. So on the left is the time chart that we have. So you can see the time as a column, and then the column, the kitchen ceiling water sensor, is averages of 100 because it's always 100% battery. But if I wanted to turn that into, let's say, by a stats, you can untable it now, a column of host. Now you can do by host again for an additional stat. So you can take it from a time chart, untable it, and then do more stats on top of that, because now you can split it again by host in a different way. So it's very efficient at doing that. Contingency These are used to record and analyze relationships between two or more, usually non-numeric or categorical variables. So you don't have to worry about summing or averages or anything like that. A contingency table just shows the distribution count of one variable in rows and another in columns, and you just study that association, and there's a few flags you can set it. It's good to do things like web analytics, browsers with versions, ages with locations of gender, anything really, but better with categorical. Here's an example. So this one is based on block type and OR, and the tool used to do it, but you just do contingency, block type, and tool used. And it just shows up block type and stone pickaxe. There's a few other options that you can adjust how this does the correlations, but it generally just counts things, but it's very quick at it. And then you can graph it on this beautiful little bar chart, and you get percentages by just looking at it. XY series, it's another one that returns results into a format suitable for graphing. XY series can help you build charts on multiple data series. So email flow, one-to-many relationships, and I'll show you that. Any data that has values independent of the field name, such as some of the Windows stuff. So the example here is your domain is splunk.com, your metric is kbps, and the metric value is 100. We can use XY series to turn that into something that we can actually chart. So we say XY series, what is the common domain, and then the metric and the metric value, and it's again good for categorical field comparison here. We're looking at weather data, so you can compare the weather icon with the different names that are associated with it, and you can see that T-Storms icon actually works for heavy, light, and regular thunderstorms and rain. So it's an easy way to correlate even things that are not numbers, and you can just look at them and be done with the correlation. Event stats it adds summary statistics to all search results. So here you can see that the 13 block types that I broke are going to have the same count on every single event that is in the result set. So this table just gives you a straight output of the event with my player name and the block type. The distinct count of the block type, which is 13 for the entire set, because I used event stats. The opposite of that is stream stats. And this does cumulative summaries on all of the search results in a streaming manner. So order of time does matter. So if you sort time differently, either ascending or descending, the numbers will come out differently. And here you can see that we started with 11 down at the bottom and we ended up with 13 at the top because we did it in a streaming order. So we calculated it that way. Another one that you could use for statistical queries for speed is tstats. You can use this on index fields and tsidx files. So you have an accelerated data model or accelerated searches, or you got it from tscollect data. You can only use it on index fields. Extracted fields will not work. And it respects the time picker to the millisecond and default searched indexes. So if you don't have access to that index or you don't define it and it's not in your default, it will not search it. But here you could do count by source type and index like we did earlier, and then do a stats and count the indexes by source type. So it's similar to our REST map metadata search that we saw earlier, but this one is much faster and more efficient. So you can do it 2 different ways. You can do it 100 different ways, but this one's more efficient. So tstats is good for very quick analytics on accelerated data here. We also have some of the Minecraft block items from an accelerated data model. And it just gives accounts, and then we use XY series to actually properly graph it. mstats is new in 7.0. It's used to analyze metrics, and now that we have the metrics workspace, you can even take this a step further without having to do the mstats, but that's what's behind the scene of the workspace. The metrics workspace is mstats. You can look at the metric store, find the title of your variable that you're looking for, the CPU idle value or CPU interrupt value, whatever your metric name is called. And then you just do average value as average, where metric name equals CPU system value, and then span it over 1 minute, and there you go. It's similar to tstats, but because it's metric store, it's mstats. So it gets very quick metrics data out and displayed. Autoregress is one that prepares your events for calculating autoregression or moving averages by copying the fields from one to another. It's basically just takes in the order that it finds them, whatever value preceded it, drops it into the next event. It allows advanced statistical calculations based on previous values, network bandwidth trending, malicious traffic trending, all sorts of trending and security use cases. Here's an example. We move the kilobytes from the first event into the second one, and then display them, and that's it. And then you can do an eval on top of this. And the eval, you can just take the difference of them. You can take standard deviations, averages, whatever, between the two values. You can also make it go P2 or P3, and then it has additional columns that have even more of the previous values, and then just do a running calculation on top of those. Streamstats will do something similar, but you can also do this with autoregress. These next ones up are SPLacks. They're not really hacks, they're documented. But there are interesting use cases for some of the weirdness that you can find in the SPL. They're not actual commands. Inline timeline eval. You can do evals directly in a timeline, in a time chart. So here you can see the example, EV2 is evaled, and then the second one is done inside of the eval itself. You'll notice that it does use different significant digits because of the way it's calculated, and if you do it in a time chart, you have to rename it. You can't just leave it as eval average over average. You have to rename it as another field. But you can see here that it's generally the same to 5 significant digits. So if that's all that matters to you, then you're fine. Dynamic eval is indirect reference. You can create fields based on values of other fields. So in this example, CNT underscore curly braces counter equals value. We're pulling this out of DNS TCP perfmon data from Windows. You can say CNT of the counter is equal to the value in the same event. So now you have CNT TCP message memory equals the value. So now you can actually use that as averages other places and not just try to guess what the value is. The subsearch dynamic eval is just another one. It's not a search command, but you can drop subsearches into just about anywhere and they will execute and run. So you can do really weird things with metadata or searching subsections of items and go from there. So using a subsearch anywhere is pretty cool. This one is being used in the middle of a replace in eval. We're going to finish up here with some CLI commands, commands that are run from the command line to help data extraction, pool configurations, know your cranes. All right, Splunk reload monitor. It reloads monitor files, inputs.conf monitor stanzas, which is great on universal forwarders. You edit the file, you reload the monitors. You don't have to restart it. Don't waste the time. Just reload it. It's great for adding new apps, especially in things like syslog data collection on universal forwarders. PC regex test is a way for testing regular expressions inside of Splunk, and you can also use them with the modular regex, which is quite interesting as well. So IP source, you define a common regex, and then it'll auto-extract it into source IP and dest IP based on the regex that you've given it already, but it tests it against a string, and it gives you the capture groups, the success, and what it matched against, and any capturing groups that it finds. So it's good if you need to actually test it against Splunk proper and not just guess if it's going to work or not. Splunk B2, very, very important if you're looking at configs. You want to make sure that you get rid of the system default stuff with the grep -v, just because you don't need the system default, because it's always going to be system default. We're looking at things that have changed. So this will tell you where the properties are coming from and what file and what app, and it follows precedence, and it's very useful for making sure that you're extracting information correctly. The next one is using Splunk command Python, which actually executes the Splunk Python interpreter, not just the locally installed Linux or Windows Python. It runs the one that's bundled with Splunk, which is important when you're trying to do modular input configuration and testing. You can pull this the mod input configuration out of Splunk D using the command here, and then you can pipe that into the Python command and run the modular input file, and it as long as no authentication is required to make it run, it'll just output on screen the results of the API calls, much like the modular input does to get into Splunk. So it's a good way to test Python files for even syntax errors or module importing if you need to track down that. Where to next? You can ignore all of this. This was from 2017. And this is a resources and questions slide. If you have any questions, you can go to Docs, Answers, Wiki, join Slack. That is the wrong URL. The new one is splk.it/Slack. So that's splk.it/Slack, and I'm sure we have it linked somewhere. Or you can find the Splunk Trust, and we have fezzes, and we're pretty cool looking, and generally have beards. You cannot rate this session in the Conf 2017 mobile app, as that no longer exists, but this then concludes the lesser-known search commands really quick brief and run through. Hopefully I didn't speak too quickly for you, but you can use this as a great reference, and thank you.